So we have the definitions of one-to-one. We have a horizontal line test. That's your B. And then vertical line test, that's just a review. That was from our very first test, so that's a little review of that. I would read this as a function f is one-to-one if for any x cannot equal x in the domain, y cannot equal y. And I'll tell you exactly what that means here in a second. So do you remember earlier in the year, I'd give you a graph and I'd ask you, is this a function? And we use something called the vertical line test.
Yes.
So what I mean by that is I would draw a vertical line down the graph, and then I would see if it ever crosses the graph at more than 1 point. So does this vertical line ever cross my parabola at more than 1 point? No, so I called it a function. Okay? One-to-one is a new concept. We're going to learn about inverses today. And in order for a function to have an inverse, it has to be one-to-one. So we're going to take that vertical line and we're going to turn it horizontal.
Wow. That was really...
So, and it's the exact same concept. It can only cross one time. That's what this means. For every f of x, they cannot repeat. So I cannot have repeated y values. In other words, this point has the same y value as this point. So this is not one-to-one. We use the horizontal line test. So it is a function. It passes the vertical line test, but it's not one-to-one. Okay? And today we're going to learn how to do something called limit the domain. So, kind of long story short, we're going to take this parabola and chop it in half. We're going to limit the domain to a certain value. And now is it one-to-one?
Yeah.
Yeah. Okay, so we'll see more of that here in just a second. This here is a relation, or it's a set of points. Okay? Remember earlier in the year we used those curly brackets for sets? It's been a while. Go ahead and take a second and plot those 4 points on the graph to the right. So we graphed the 4 original points. Now, we're going to find something we call the inverse of the relation. The inverse means we take the x and y coordinates and we switch them. So down here, let's write a new curly bracket. We're going to write a new set. We're going to write the inverse set. So we're literally going to take each point. I'm going to use a different color. Say 5, 0 backwards. 0, 5. We're going to take the x value and the y value and we're going to switch them backwards. Okay, now switch the second point and we get -2, 8. The third point would be 3, 10. And the fourth point would be -7, 2. And then plot those 4 new points. Okay, what do you notice about my red points and my purple points?
They are the same shape, but it is shifted.
It is shifted, and it's kind of hard to tell with this shape, but it's not just translated. It's not slid. It's actually reflected. Good. So, and it's actually reflected across this line right here.
Y equals x.
And that is answer C on your pretest. A graph for an inverse is reflected across the line y equals x. In other words, what's the y-intercept of y equals x? If it's not there. 0 crosses the y-axis at 0. And what's the slope of the line y equals x? 1x, which is f1 over 1, f1 over 1, f1 over 1. So that's that diagonal line that splits through quadrant 1 and 3. Take a look at, we're now switching from a relation, which is discrete. It's just like 4 separate points. It's different points in a set notation. A function is a smooth curve or line, and we know how to find out if something is a function or not, but this here is a function. It is the function, the square root of x minus 6. And we're going to follow these 4 steps to find the inverse of a algebraic function. So the first step, it says change f of x to y. We know f of x is our outputs. It's our y values. So I'm just going to rewrite this as y equals the square root of x minus 6. Okay, step 2. Switch the variables x and y. And only the variables x and y. So now I'm going to rewrite this as x equals the square root of y minus 6. Notice the square root didn't move. The minus 6 didn't move. Even if there's an exponent, like let's say this was an x squared, and I have to switch x and y, the squared doesn't move. It just becomes y squared. You only change the letter, the variable. Okay? And then step 3, we just have to resolve the equation for y. We need to get y by itself again. So Samantha, what is the first step to undoing this square root? We need to get y out of the cave. We don't square root it. The square root doesn't undo a square root. What undoes a square root? A square. If you square a square root, they cancel out. Those are inverses of each other. So we left with y minus 6 equals. If you square one side, you need to square the other side. So this just becomes x squared. And then what's the only thing that I need to do to get y by itself? Just add the 6 over.
Wait, why didn't you?
So now we're left with, I'm going to write y on the left equals, what's on this side? X squared plus 6. So, and then the last step, step number 4, the way we name an inverse, we just write it as f to the negative first of x. So that's nothing more than just kind of like the way we identify it, just like you guys have names. So I'm going to rename this, like if this was a test or there were directions, it might ask you to find f to the negative first of x. That means find the inverse. So let's just get in the good habit of writing it like this, and that is your answer. That is the inverse of the square root of x minus 6. And graph our original function that we just started with, the square root of x minus 6. If you don't remember what that looks like, just open up your calculator, go into y equals, and graph the square root of x minus 6. So there's the graph of this square root of x minus 6, domain and range. Now, let's put a little equal sign here, because we've already done this. We've found the inverse of the square root of x minus 6. What was our answer about 2 minutes ago? X squared plus 6. And let's graph that. You should know at this point what that looks like. There's no parentheses, so it hasn't moved left or right, but what's a plus 6 out back to? Up 6. So this is a parabola that has been moved up 6. And it wasn't stretched or compressed. So it's just that normal shape that goes through the point over 1, up 1. And now, I'm not going to ask you the domain and the range of the parabola. I'm asking you the domain and the range of the inverse. And if you go up here and read step 1, it says, the domain of the function becomes the range of the inverse. The domain of the function becomes the range of the inverse. And the range of the function becomes the domain of the inverse. Now notice that is not the domain and range of that parabola, because what's a parabola, what's a quadratic's domain always going to be? All real numbers. But it's not just a quadratic, it's the inverse of a function that began with originally, something else. So now, what this is telling me is this quadratic, this parabola, only exists here. So we need to chop part of it off. What's the furthest left that this parabola can go? 0. And to the right forever. So don't do this yet. I'm going to do it. But literally, basically what this is telling me I need to do, I need to remove everything to the left of 0. Now, if you check the range is actually already good, right? The range says 6 and up. And it is 6 and up. Okay? So now our last graph says put both of these together. So take the square root function, which was 6 and to the right. Take the quadratic, which was up 6. And what do you notice about a square root function in the right half of a parabola? They're reflected across the line y equals x. They're exact opposites of each other. They're inverses.